today is the 10th. Okay, today is October the 10th. The agenda is on the side board. Please make sure that you write your homework in your planner. Please make sure you complete the homework. Do not forget that the technology project is due next Friday. So you already know if you hadn't gotten at least almost completed, okay? You should be almost finished. Then you need to start working on that. You need to start writing that down as a part of your homework because you only have one more in-class day to do this. Yes. Math technology project. Take your hood off, baby. Okay, baby. Okay, so make sure that you watch the help video. The help videos on Canvas, and Miss Reyes will send it out and remind later on this afternoon. Okay. All right. The agenda, you do not have to write the agenda. I'm doing this for the video. You need to make sure today that you write your homework. Okay. Complete the warm-up. I'm going to give you a minute or so to complete your warm-up. We're going to go over the warm-up and the review test question. Please don't do that, baby. Okay. The review test question, I'm going to go over that as well. After which, I'm going to model reflection again with the sheet that we did on yesterday. And then I'm going to go into rotation. I'm going to model rotation. There is a foldable that we're going to do on rotation today that I've already put on your desk. All right. And that is where we're going to get some guided practice in. And we're going to do more work with rotation tomorrow. Okay. Which is the third transformation that we're talking about. All right. Let's turn over to the warm-up. Perimeter is the distance around. It's the distance around. Okay. It says find the length of AB. This is the length right here. Okay. So it's telling you that perimeter or P is equal to 28 inches. And you're asked to find the perimeter. So let's set this up. And then I'm going to give you time to work on it, okay? All right, so here we go. Perimeter is where all the sides, you add up all the sides. All the sides added together is 28, which is going to be equal to 2x minus 6 plus another 2x minus 6 plus x. I'm going to give you time to answer this question. I'm going to set my timer for 5 minutes. Also, I'm going to turn back to this page. Just give me a second. Also, I need you to see if you can answer this question here. Okay? See if you can answer this question here. So you have 2 things that you're going to do, and I'm going to set the timer for 5 minutes. Yes, baby. This is 2x minus 6 plus 2x minus 6 plus x. Okay? All right. See if you can do that. I'm setting the timer. Let people concentrate, okay, baby? All right, good folks. Let's look at it. When you're solving an equation, the first thing you need to do here is look for distributive property. There is no distributive property. So now we're going to combine terms that are alike. Bring down the 28. 28 is the only number that's on that side. So bring it down. Nothing to combine there. It's the only number that's there. Pause. What's the cause, miss? Be quiet. Yeah, and I'm just giving you a response. Don't forget to write that down, please. Okay, look. 28. Bring down the equal. The terms that are alike here, you have 2x plus 2x plus 1x. Okay? So you're going to add those together. 2x plus 2x gives us 4x plus 1x gives us 5x. So we have combined all the x's together. Now we need to combine the -6 and the -6. -6 plus -6 gives us a -12. So that's the first thing that you do. Combine terms that are alike. Now you can start isolating the variable. You can start solving for the variable. So in order to solve for the variable, get rid of anything you can add or subtract first. The number that's not directly attached to the variable is a -12. What is the inverse of a -12? Plus 12. So in order to get rid of the 12, we have to add 12 on both sides. Person 2. When you add 12 on this side, this gives you 10, carry the 1. This gives you 4. So we get 40 on this side. That's 0. And we're left, take your hood off, baby. We're left with 5x. So now, the operation between the 5 and the x, write this down, Christian. The operation between 5 and x is multiplication. What's the inverse of multiplication? So we're going to divide both sides by 5. So now what we have is 40 divided by 5. What's 40 divided by 5? 8. So x is equal to 8. Please write that in. I'm going to pause for the calls. All right. Raise your hand if you're still writing. I can't tell who's still writing.
I'm writing.
Okay. All right. All right. So now let's look at the review question. All right. This is one of the questions that many of us miss. So we need to go over it. It says a student placed 10 numbers shown in the Venn diagram. These are 10 numbers shown in the Venn diagram. It says, which Venn diagram shows the relationship of the numbers? So remember, they're not going to overlap because it's either rational or irrational, okay? So let's look at the answer choices. We have here, this number, check, that is rational. A mixed number is rational. An integer is rational. This is not rational. So A is not the answer. Shh. Let's just get through it, please, okay? Rational number. This is rational. A fraction or a mixed number is rational. This is rational. You can write that as a fraction. You can write 0 as a fraction. And this is a fraction. All of those are rational. The square root. This answer is a decimal. When you do the square root of 2, it is a decimal. That's rational. This is also rational. But the square root of 25 is not rational because the square root of 25 is equal to 5. This is not right. B is not your answer. Okay? This is also not right. You can write a repeated decimal as a fraction. This is correct and this is correct. The answer here would be a decimal. That makes it irrational. C. This repeated decimal, that is rational. You can write it as a fraction. This is already written as a fraction. -1 is a fraction. The square root of 25 is equal to 5. You can write that as a fraction. This is correct, and 0 is also rational. Irrational. This is irrational because the answer is a decimal. This is irrational because pi is irrational. The answer here is also a decimal. The answer here is also a decimal. C is the correct answer. Okay? D. This is correct, but this is not correct. This is not correct. This is correct, this is correct, and this is correct. Over here, this is correct. The answer is a decimal. This right here is not correct. It can be written as a fraction. It is a fraction. This is not correct. This number could be written as a fraction. However, the negative square root of 30 is a decimal answer. It is correct. The best answer here is going to be C. Questions, comments, or concerns? Please make sure that you make all the markings that I have made so you can get 100% credit. I'm going to pause for the calls. All right, take out your reflection. Shh. Do I have everybody's reflection sheet from yesterday? Did you turn? Raise your hand if you did not turn in your reflection sheet from yesterday. I need it. If you didn't turn your reflection in from yesterday, please turn it in. Shh. It was the worksheet that we did in class. It has reflection at the top. Shh, everybody should have turned it in. I need you to turn that in. Well, pause for the calls, please. Put the whiteboard in front of you. You need a whiteboard. Clear your desk of everything except for the whiteboard. On your whiteboard, please turn to the side that has the lines. Please turn to the side that has the lines. I'm sorry. Please turn to the side that has no lines. Lord, please help me. Okay, so we're going to do rotation. Shh. Rotation is going to be a rigid transformation. Is a rigid transformation. Ms. Reyes, why is rotation a rigid transformation? A rigid transformation are going to be transformations that when you perform them, it doesn't change the shape or the size. Turning an object does not change its shape or size. That makes it a rigid transformation. Sliding an object does not change its shape or size. So translation is a rigid transformation. Flipping an object does not change its shape or size. So that is a rigid transformation. So there are three rigid transformations: translation, reflection, and rotation. Dilation is not a rigid transformation because the size changes. That is the only transformation that is not rigid. All the other ones are rigid. All the other ones, I'll give it to you. All the other ones are rigid. Okay? All right. So let's do it. What is rotation then? Rotation is not just a rigid transformation, but it's how we turn an object on a coordinate plane. Let's leave the door cracked until we finish our breaks, okay? Here. Sorry, babe. Shh. All right. So it's how we turn a shape. Leave it open, babe. Thank you. What number are we on? Guys, I'm going to cut out the bathroom break if we start this playing stuff. Okay, I need you to go sit down, sir. All right, so it's how we turn it. How do we turn it, Miss Reyes? We're going to either turn it clockwise to the right or counterclockwise to the left. The hands on the clock go to the right. So it's two turns that you can make. You can either make please listen, clockwise. Clockwise is to the right. Okay. Clockwise is to the right. Counterclockwise is the opposite of that. That is to the left. Okay? Counterclockwise is to the left. That's this way. The hands on the clock, tick, tick, tock, go this way, to the right. So clockwise is to the right. Counterclockwise is backwards, is to the left. The abbreviation for clockwise is CW. The abbreviation for counterclockwise is CCW. It's okay. Do not erase the board because we're going to refer back to this here in a minute. But I do need for you to turn the board over so I can show you how to turn, okay? We're going to do a triangle, okay? Let's do negative 1, 2, 3, and positive 1. Let's label that A. A. Negative 3, positive 1, A. Shh. Negative 3, and positive 5. 1, 2, 3, 4, 5. B. Negative 3, positive 5. And let's do negative 6. 1, 2, 3, 4, 5. Negative 6 and positive 1, 2, 3. Let's label that C. Okay. Please graph those ordered pairs. This is going to be my pre-image before the move. So now we're going to practice turning so you'll know how to do these turns, okay? We're going to practice turning so you'll know how to do these turns. Hold it up so I can make sure that everybody has the correct drawing. Very good, baby. Very good. Very good. Very good. Very good. Very good. Very good, sweetie. Very good. Turn around. She's upside down. Your picture's upside down. All right. Shh. Here we go. Good job, baby. Shh. All right. Here we go. Shh. What you need? Another marker? What's wrong? Okay. All right. Okay, good folks. Look at this. First, I'm going to start off with a 90-degree. Shh. Guys, please listen, because let me explain this to you. This can be this is one of the harder ones to do. I'm just going to be right up front with you. So I want to take my time to make sure that you understand it to make it less difficult. But if you're not listening, it's going to really be hard for you. Okay? So please listen so you can get it right. When you do a 90-degree turn, look at my hand. A 90-degree turn looks like this. It's a box shape. Okay? It's a box shape. This is a 90-degree angle because it's a box. All right? So when you turn 90-degree angle, when you're doing a 90-degree turn, it's actually one turn. Okay? Because look, I'm going to move this line from here to here. Okay? I'm going to move this line from here to here. That's a 90-degree turn. So when I turn 90 degrees clockwise, I pick my graph up and I turn it one time this way. That's a 90-degree turn. That's it. That's all. So if I'm doing a 90-degree turn clockwise, this is where my new points would go. Turn it back the correct way. Okay? If I'm doing a 90-degree turn counterclockwise, that's to the left one time. So pick it up and turn it this way. Now my image is down here. That's a 90-degree counterclockwise. All right, turn it back. So now we know 90 degrees is one turn. If you do 90 degrees one turn clockwise, it's to the right. 90-degree turn counterclockwise is to the left. Okay, so now let's do 180. 180 is 90 plus 90. So that's two turns. 180 again is 90 plus 90. So that's two turns. So let's do 90 degrees. 90 degrees clockwise. That's to the right two times. This is one time, two times. It's upside down. It looks just like this. This is a 180 degrees clockwise. Look at where it is. It's in the third quadrant. Turn it back the correct way. All right, so let's do a 90 degrees counterclockwise. That's two to the left. One, upside down, then two. Look, it's in the same place, is it not? Okay, so when you're doing a 180 degree turn, they're not going to say clockwise or counterclockwise because it's going to end up in the same place whether you turn it to the left or to the right. So 180 degrees is two turns. Okay? Turn it back the correct way. So now we got another turn. We got 270. 270 is 90 plus 90 plus 90. So, Mickey, that's going to be 3 turns. So, 270 is 3 turns. So, we're going to do 270 clockwise. That means to the right 3 times. Let's pick it up and move it. 1 turn, 2, 3. This is where it is in that third quadrant. This is a 270, 3 turns clockwise. Turn it back in the right direction. Now we're going to do 270 counterclockwise. That's 3 times to the left. Okay? So let's do it like this. 1 time to the left, 2 times to the left, 3 times to the left. It's just like this. Okay? Any questions about that? So now I'm getting ready to test you. Let me pause for the calls. Some of my words got kind of messed up, but that's okay. Look, a 90-degree turn. How many? You write it. How many turns is a 90 degrees? How many turns is a 180? How many turns is a 270? And then 360 is back in the same place. It's 4. I'll give you that one. Okay? It's like if they say 360, just write those points down because it's going to look like it didn't even move. It's just turned all the way around and back into the same place. So you tell me the number of turns and hold it up so I can see it. Perfect, 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 perfect. Come on. Come on. The number of turns, okay, baby? 90, 180, 270, 360. Perfect, 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 perfect. Yes, that's right. Can you please stop doing that? It doesn't serve you well. Very good. Very good. All right. Okay, so now 90 degrees is 1 turn, 180 is 2 turns, 270 is 3 turns, and 360 is 4. Okay? All right. Any questions? Okay, good, folks. Now I need you to put your markers in the same container as the scissors. I need you to put the glue sticks and the erasers in the same container. Okay? And I need you to clear your boards and put your boards under the basket. Pause for the calls. All right, so with the foldable, you're going to take your pair of scissors. We're going to turn it on this side. Do you see where the little dotted lines are? You're going to cut. Cut the dotted line. Cut the dotted line. I know, I'm sorry. It's just not. I did it wrong, but that's okay. We're going to make it work, okay? Yeah, we're going to make it work. We're going to make it work, y'all. Yeah. You can cut on the dark line if you see it. All right. Converse, did you cut already? Come on, need you cut, baby. Leave him alone, please. All right, look. Now we're going to fold these over. We want to be able to see this tab. The first one we talked about is 90 degree counterclockwise. Bless you, baby. Then we got 180 counterclockwise. Bless you, baby. And we got 270 counterclockwise. Some of them are going to be very similar to each other. And we're going to talk about those similarities. We might need our whiteboard so we can physically see it, but I'll let you know when we cross that bridge. I'll let you know. All right, make sure that your foldable looks like this. And pause for the calls. Okay, good people. Counterclockwise, the abbreviation for counterclockwise is CCW. And counterclockwise means that you're moving to the left. That's backwards. Again, counterclockwise is CCW, and that means you're moving to the left. Please write it. Counterclockwise, again, is CCW, and that means you're moving to the left. That's the opposite way that the hands on the clock is moving. The hands on the clock move to the right, which is clockwise. Counterclockwise is the opposite of that, which is to the left. It's to the left, okay? All right. We'll talk about the rules. We'll write these rules down a little bit. We'll go ahead and do it. We'll just write it in, but I'll describe the rule later, okay? So here, you're going to write negative yx. Here, you're going to write negative x, negative y, and we'll talk about that later. And here, we're going to write y, negative x, okay? And we'll talk about it later. Later. That's all the front. That's another discussion for another day.
Are we doing the inside?
We're going to do the inside, yeah. All right, good folks. So let's do one at a time, okay? Let's talk about 90 degrees counterclockwise first. Remember, 90 degrees is one turn. 90 degrees is a one turn. That's what I noticed too. Lord help me, Father. All right, open up the tab. A 90-degree clockwise is the same as a 270 clockwise. And I'm going to show you that. Let's go back. You do need this again. Let's go back to our whiteboard again. Pause for the calls, Miss Reyes. Graph again, sweetie. We got A is -3 and +1. B, -3 and +1, 2, 3, 4, 5. And C is -6 and +1, 2, 3. Just graph them again, okay? Bless you, babe. All right. So now we are going to do we're going to prove that a 90-degree counterclockwise, which is actually one turn to the left, is the same as a 270 clockwise, which is 3 turns to the right. Please write that in. And we're getting ready to prove that they are the same. All right, ready? Okay, Miss Reyes, let's prove it. So a one turn to the left, we're going to pick our board up and we're going to turn it one time to the left. And look at where it's located. It is located here. Do you see it? We got A here. See if you have a photographic memory. We have A, B, C on the bottom. Okay? Turn it back the correct way. Now we're going to do a 270. That's 3 turns to the right. So look, let's turn it. 1 to the right, 2 to the right, and 3 to the right. And look, it's in the same place. A, B, C. So a 90-degree, look, a 90-degree counterclockwise, which is one turn to the left, is exactly the same as a 270 clockwise, which is 3 turns to the right. Any questions about that? Yes, baby. It's not the same. Okay. All right, let's do the next. One turn to the left, 3 turns to the right. They are exactly the same. Any questions about that? All right, here we go. Next. 180. A 180 turn is going to be 2 turns. It's 2 turns to the right, clockwise, and it's also 2 turns to the left. So whether it's to the right or to the left, it's the same. All right, so let's prove it. Shh. Calm down, please, sir. Shh. All right, turn it the right way. Are you still writing, Ashley? Yeah. Okay. You got it? Shh. Converse, make sure you have the script, baby. Mm-hmm.
Annabelle, don't do that.
Shh. All right, here we go. So now we're going to do 2 turns to the right first. So let's do 1, 2. Notice where it is. We got AB here, and we got C out this way. You see it? See if you got a photographic memory. AB, and then C is out this way. Okay, so turn it the right way. So now we're going to do counterclockwise. That's 2 to the left. So let's pick it up. We got 1 turn to the left, 2 turns to the left. You see how it's exactly the same? AB here, C is out this way. So no matter if you turn it to the right or to the left, 180 degrees clockwise and counterclockwise are exactly the same. Okay? Any questions about that? Shh. All right, let's do 270. Shh. Okay, so here again, guys. All right, so now we're doing 270 degrees counterclockwise. That's to the left. Ansley, you okay, baby? You okay? Okay. That's 3 turns to the left. All right, let's open this up. Now, 3 turns to the left is the same as 1 turn to the right. So let's write it. 270 counterclockwise is 3 turns left, which is going to be the same as 90 degrees clockwise, which is 1 turn to the right. And we get ready to prove it. Please write this down. They are going to be the same. Please write this down. All right, let's put our board in front of us again. Put it the right way. It's like this. The first one that we are going to do is the 3 turn to the left, 270 degrees counterclockwise. So that's 3 turns to the left. So let's pick it up. This is 1 time to the left. This is 2 times to the left. This is 3 times to the left. Notice it's in the first quadrant. The C is right here on top. We got A and then B. Okay, notice how we got A, B, C is on the top. Okay, all right, let's turn it the right way. Let's turn the right way. So now we're going to do 1 turn to the right. Okay, so let's pick it up and let's move it 1 turn to the right. And what do you know? A, B, it's down here at the bottom like it was before, and C is at the top. They are exactly the same. Okay, so a 270 degree turn counterclockwise, 3 turns to the left, is exactly the same as a 1 turn to the right, which is 90 degree clockwise. Yeah. They are exactly the same. Do you see that?
Yeah, I was asking with counterclockwise, no matter how you turn it, are they still gonna be the same? Like, are they still gonna be the same return?
For these 2, yes, are gonna be the same. These 2, yes, are gonna be the same. These 2, yes, are gonna be the same. Okay, those are the ones that are the same. All right, so Time is it? I did good. All right. So listen. Please, please, please listen, because I be trying to get to a certain place with us so we don't get behind. All right. So look, I want you to try this one on your own. I know, Miss Reyes is crazy. She teaches middle school, so she has to be crazy. All right. So look, 90 degrees, underline it. 90 degrees counterclockwise is going to be one turn to the left. Okay? So instead of you doing it, let's do it together, okay? What was you thinking, Miss Reyes? You crazy. All right, so now we're going to pick this figure up and we're going to move one time to the left. You ready? So one time to the left is this way, just like this. You see it? Your paper should be just like this. I'm going to zoom in so you can see. So this is where the object needs to be. It's going to look just like that in that second quadrant. We're going to write down these new ordered pairs so we can graph it. Look at the new location for A. The new location for A is to the left one and up 1, 2. So A prime is going to be -1 and +1, 2. So let's write it. A prime, the new location for A, is going to be to the left one time. Is it left one time? Yeah. And then up twice. And put this in your folder. We'll finish it tomorrow.